Hi, in this video we will extend the idea that we had in the last video when we talked about the Line+Noise model fitting. And we discussed how you would actually do that in a data set. It was a generated data set, but that's a good way to learn the process. But now what we would like to do is extend that to forecasting. So the topic of this video is Line+Noise model forecasting. And how would we do that? And if you'll recall in that last video, we actually had a shortcut command that really stepped into this video because it gave a forecast syntax command, but I didn't say much about it, and I said that I would be focusing on it in this video. So we're here to that point now, and we'll go do that. Again, QR 8.5, so we're in chapter 8, Line+Noise forecasting. And as I mentioned, let's think about, again, that data set we had in the last video. It was called X1. It was in example 8.2. And it was a Line+Noise model that looked like this. And this is how we generated it. Gen for generate, sig plus noise.wge. We have a length of 100. That's going to come into play here in a minute. So the length of this realization is actually in as 100. We know that our beta naught, our B naught, that is our intercept term, is 10. And our slope term, B1, is 0.1. And our phi, that's of the ZT piece, right? That's of the error term, is 0.9. So phi is 0.9. And the seed number is the same as last time. So when we run this, it's going to look familiar because we've already worked on this. As I said, it's just an extension of the video before. There it is. That's our realization for that particular seed of this model. And we did this last time as well. We said, well, let's run a simple linear regression on this, because remember why. Remember that I might should have put this command in. It wouldn't take long to run, but remember we don't just jump in and say, oh, I want to do a simple linear regression on it. We had to first of all convince ourselves that it truly was a line, and the WBG bootstrap test does that. Remember, the p-value was 0.03. Go back and look at the previous video if you want to check that out. And besides, we knew this was a line anyway because we generated it to be one, right? But let's look at and see what happens when we do slr.wge of this data set. We'll run that and we get a bunch of output. Here it comes. It'll look familiar. There's our B hat. That was 12. I'm just going to start using command return so I don't have to highlight all that. B1 hat is 0.059. So again, 12 is pretty close to 10, the actual. 0.059 is pretty close to 0.1, which is actual. Here are the residuals, just be a bunch of numbers, 100 of them. This AIC term comes back null. I'm not exactly sure why off the top of my head. Let's keep going. It's not important. Here are the phi values. There's 3 of them because it shows an AR3. And here's the variance of A, 0.97. Again, that's exactly what we saw in the video before. So far we've done nothing new. Now, let's focus more on this forecasting command. And what we're going to first of all do is look at the forecasts of the residuals. Now that may sound a little bit strange because you are probably thinking to yourself, I don't want the forecasts of the residuals. The residuals don't do me any good. The whole purpose of this this chapter and this exercise is I want the forecast of the data set, not of the residuals. But recall that the way that these forecasts of the actual data set are found is to first of all find the forecast of the residuals, then convert those back to the actual x's. So the residuals you can think of as the z's, and then we're going to convert those back to the actual values. And that's how this works. So let's go ahead and run this line and look at the forecasts of the residuals and get a plot of it. Notice the arguments are the data set. Well, that's just the residuals from this XA that we just asked for. Then here would be the phi coefficients. We talked about those. There's 3 of them. And then we want n dot ahead 25. Remember what that does? That gets 25 forecasts in the future. Let's run this just to take a look at it. And there it is. Now let's look at this closely and see what we're finding. What we have is the forecasts are in red. The last actual value was up here at 100, 101, 102, 103, all the way out to 125. And what do you notice? You notice that the last value was here. The forecasts start sliding downward, and then all of a sudden, they, as a screeching halt, they quit going down and they flatten out. Wonder why that would be. Notice where we're at. We're at the line 0. That's why it flattens out there. Remember that these residuals have a mean of 0. So the expected value is 0. Now, what happens is they don't get there immediately. They gradually make their way down there. And that's why that's important. What are the blue lines? Remember, those are the limit lines. Those are the limit lines. So that is the plot of the forecast of the residuals, not of the data set we're trying to model, but of the residuals. Now you'll see why that comes into play. What we do next is we set up a counter from 101 to 125. Then this is the conversion. We're now converting those residuals forecasts into our actual forecasts. We're going to, that TF that we just set up, we just defined, we're going to multiply those by the B1 hat from the XA object and add it to the B naught hat, the constant term. And that's how we convert back to actual values. So let's do that. And then we'll look at those. What do you expect in here? We expect 25 values, don't we? We expect 25 forecasts. And we mean the actual forecast, the forecast of the X's, not of the residuals. Run those, there they are. A lot of 18s to start off with. Up to the 19s. And now let's plot those. So there is the syntax in order to plot the forecasts. Now you wouldn't have to go through all of those steps. You could have just come here immediately, because X1 was generated a long time ago. All this stuff we did on the in between now, then and now, was just to learn about the process. But there is your forecast plot for the X's. Now, before we stop here, let's talk about this. Now, if you look at this, you're thinking, wait a minute, that plot before was flat. Why is this not flat? Well, remember that forecast before was of the residuals, and we knew that the residuals have a mean of 0. The expected value is 0, so therefore those forecasts are going to eventually, actually pretty quickly, tend towards 0 and stay there. Well, because of that, then it would make sense that when we convert back to our X's, and remember we had already determined that this is a line that's going to persist, then these forecasts will gradually tend towards the line. So let me do this with my cursor here. The line comes in here like this. And our last value was up here at 100. And what do we notice that the forecasts do? The forecasts make their way down towards that trend line. The trend line is coming in here like this, and the forecasts make their way down to that trend line, and then they decide to ride that trend line. Just like what? Just like the residuals made their way down to 0 and rode that line. And those are completely related. And that is the way that we use our syntax, our TSWGE, in order to calculate the forecasts for a line+noise model. So pretty straightforward. TSWGE does a lot of handy stuff, and it does it quickly, succinctly, very simply. Again, I've had a couple of videos here in a row where I do quite a bit of explaining and throwing in extra steps that you don't necessarily have to do if you're trying to just get these forecasts. So keep that in mind, but it's good to know where everything comes from, and then once you learn how, it's fine to just go ahead and go to that last line and just use the forecast command. But I hope that makes things easier, and if you have any questions, you can look at the text again and look at that in detail, and I think that it'll make sense to you. See you next time.